Every day, the Earth experiences minor tremors that we can't feel. But why do these tremors happen anyway? In 1912, Alfred Wegener proposed the continental drift theory that explains the breaking and drifting of the continents. The idea of Pangaea was born but was quickly rejected due to the lack of scientific evidence. Recently, scientists have been able to study the Earth's interiors using seismic waves, allowing us to see the changes that occur within the Earth. This layer here is called the asthenosphere. It undergoes convection currents due to its plastic-like state and extreme temperature. It's sort of like how leaves in a pond move with the current of the water. Similarly, the convection currents move the little sphere on top and affects the plate's locations on the Earth. This makes it possible for them to move toward each other, away from each other, and even against each other. Maybe you don't know what plates are. They're fragmented pieces of the Earth's lithosphere. They're like pieces of a puzzle that interact with each other. Sometimes, when the plates move, you can feel it and you call it an earthquake. But what exactly is an earthquake? According to Merriam-Webster's online dictionary, an earthquake is defined as the shaking of a part of the Earth's surface that can cause great damage. But scientifically speaking, an earthquake is the result of the release of energy from the breaking of rocks. Geologist Henry Reed was able to explain this phenomenon through the elastic rebound theory. It explains how elastic energy is stored in the crust when it moves. It then releases the energy when it breaks apart, creating seismic waves and causing an earthquake. It's similar to stretching a rubber band. When you stretch it, you apply stress, similar to that caused by plate tectonics. This results in the buildup of elastic potential energy. Now, when you apply too much stress, it'll cause the rubber band to break and release the energy. The same goes for the Earth's crust. Bend, break, snap. Now, why are we telling you this? We're sure you've heard the news of the big one happening soon. Knowing these geological phenomena occur will allow you to better prepare for geology-related hazards such as earthquakes, aftershocks, tsunamis, and fires. The Earth is a dynamic planet where geological processes take place both internally and externally. These processes can cause harm to humans and their environment. Society must make use of current technical knowledge to prevent and intervene in an emergency. Geohazards occur suddenly and can cause great damage to people and objects. Floods. The most common geological hazards can be catastrophic. Floods are caused by sudden change in water level. Tsunamis. A series of enormous waves created by an underwater disturbance like earthquakes, landslides, volcanic eruptions. Earthquakes, one of the most destructive, caused by the shaking and vibration on the surface of the Earth. It can cause massive damage and destruction, but cannot be predicted. All these hazards happen because of the Earth's inner layers that move the surface. These phenomena are of great concerns to humans, not only because they cause the most harm to human life and property, but also because they may be worsened by our practices. But the most important thing about knowing these hazards is that we can do something to lessen its impact.